Imagine our planet, a beautiful blue sphere spinning in space. At its very top and bottom are two magnificent crowns of white. These are the Earth's poles, the Arctic in the north and the Antarctic in the south. Both are realms of ice and snow, places of extreme cold and stunning, stark beauty. For much of the year, a brilliant sun hangs low over vast, frozen landscapes, casting long shadows that stretch for miles. It is a world that seems both silent and timeless. But these two polar regions, while they may seem like twins, tell very different stories. They have unique characters, shaped by land, sea, and the subtle tilt of our world. The Arctic is not a landmass, but a vast ocean basin, the Arctic Ocean at the North Pole. Much of it is covered by shifting, cracking sea ice. The ice expands in winter and retreats in summer. Around this frozen sea lie the northernmost coasts and islands, including Russia, Canada, Greenland, Norway. An ocean ringed by land, this is the Arctic. It connects to other oceans and land masses, creating a surprisingly vibrant, interconnected ecosystem across the northern hemisphere. Unlike Antarctica, the Arctic has been home to people for thousands of years. Indigenous communities have developed extraordinary ways of life, attuned to the rhythms of the sea, the ice, the seasons. They've learned to hunt seals on the ice, to fish in cold waters, to travel long distances by dog sled and by snowmobile. Now let us travel to the opposite end of the Earth, to the Antarctic, sweeping ice and jagged mountains under a deep blue sky. This is a world of a completely different character. Antarctica is a true continent, a colossal landmass larger than Europe, buried under an immense sheet of ice. This ice sheet is ancient and extraordinarily thick. In places, it reaches depths of nearly 3 miles. Its weight has pushed the underlying bedrock down, in some areas below sea level. The continent is surrounded by the vast, stormy Southern Ocean. It is the coldest continent. It is the driest continent. It is the highest continent, a place of isolation and extreme conditions. Antarctica is almost entirely without permanent human residence. No towns or villages. Only researchers, scientists, and support staff living in research stations for months at a time. They drill deep into the ice to read Earth's past climate and observe the incredible life in the surrounding ocean. Research outposts are tiny specks of warmth in an empty, silent landscape, a natural laboratory. One of the most striking differences between the two poles is their temperature. The Antarctic is, by a significant margin, the coldest place on our planet. Winter temperatures on the high interior plateau can plummet to below -80 degrees Celsius. In contrast, Arctic winters are typically 20 to 30 degrees warmer. This difference comes from the fundamental geography of each pole. The South Pole sits on a vast landmass, Antarctica. The North Pole sits over the Arctic Ocean. Land loses heat much more quickly than water. Antarctica's thick ice sheet sits on solid rock and radiates heat into space, especially in winter. The Antarctic ice sheet averages over 2 kilometers in elevation, the highest continent. Higher altitude means colder air, so Antarctica's altitude makes it much colder. Ocean currents also matter. The Arctic connects to warmer Atlantic waters. Warm, salty water flows northward beneath colder Arctic surface water. That subsurface heat release warms the Arctic basin from below. In the south, it's the opposite. The Antarctic circumpolar current circles Antarctica, isolating it from warmer waters. That current locks the cold in. Wind patterns reinforce isolation. Katabatic winds push warmth away and help form sea ice around the coast. The most surreal feature of life at the poles is the behavior of the sun. For those of us in temperate zones, the sun rises and sets every 24 hours. But near the poles, this daily rhythm breaks down completely. This happens because our Earth does not spin upright as it orbits the sun. It is tilted on its axis by about 23.5 degrees. This tilt creates our seasons. It also causes the poles to have months of continuous daylight and months of perpetual night. During summer in one hemisphere, that pole tilts toward the sun. Near the pole, the sun appears to circle the sky without dipping below the horizon. This is the famous midnight sun. For weeks or months, there is no night. Constant daylight fuels a massive burst of life. Algae blooms, plants surge, animals raise young. As Earth continues its orbit, the pole begins to tilt away from the sun. The sun sinks lower each day, until one day it doesn't rise at all. That marks the start of the polar night. Darkness or prolonged twilight rules for months. The moon and stars can blaze, and the ethereal aurora dances across the heavens. The effect begins at the Arctic and Antarctic circles, growing longer toward the poles. At both poles, the sun rises once and sets once each year, roughly 6 months of day and 6 of night. Life in these extreme environments is a testament to the power of adaptation. Every creature and plant that survives at the poles has developed special tools to cope the immense challenges of cold, the dramatic swings between light and dark. Animals have thick layers of blubber, dense fur for insulation. Arctic foxes change coat color, brown in summer, white in winter for camouflage. Penguins huddle together in vast groups, sharing warmth during the brutal Antarctic winter. Life has not just survived here, it has found ways to thrive. The poles may seem remote and disconnected, but they play a vital role in regulating the health of the entire planet. The vast white ice sheets act like giant mirrors, reflecting the sun's energy back into space. This helps to keep the Earth cool. Cold, dense water forms in the polar regions and sinks. It drives deep ocean currents that circulate heat around the globe, influencing weather far away. What happens in the Arctic and Antarctic does not stay there. It has consequences for us all, affecting our weather, affecting the level of our seas. Today, these critical regions are changing at an alarming rate. Warming is causing the ice to melt faster than ever before.